Good morning, everybody. I hope you're all having a good, great, grand, wonderful day. We're going to try this one more time. I have tried to shoot this video several times, and there always seems to be some kind of glitch or hang up, and so we're going to try it again here. And first of all, what I want to do is I want to talk to you about trig. So we've had this introduction to trig where we understood that trig was this collection of functions that all have the input of an angle and the output of the ratio of two sides of a right triangle. We kind of tried to then show here's a right triangle, so therefore the sine of angle A would have to be the opposite over the hypotenuse. The cosine of angle A is the adjacent over hypotenuse, and the tangent is the opposite over adjacent. We talked about SOHCAHTOA. We went from there, and then we kind of brought in a calculator and said, well, if you have a calculator and you type sine of 43 degrees, what does it give you? And it gives you some weird decimal number. You can do cosine or tangent, same thing. And it gives you these weird decimals, but those decimals are a ratio of two sides of a right triangle. We just don't necessarily see the right triangle. And then we kind of put those two things together where I gave you a right triangle that had some information, and using what you know about trig, you figured out more information, and you could figure out these missing sides. And then we introduced angle of elevation and angle of depression, and with that we were able to do some kind of beginning of application problems. And then we did some real application problems that were pretty challenging. And then lastly, I had you go out and create two made up application problems that kind of involve the real world around you, but you were just kind of making stuff up about it. And so now my challenge is to get outside and try it. In this real world that we live in, you can really use this. If you all were here on campus right now, we would be walking around outside and giving this a try. I'd be giving you tape measures and protractors and ways to measure everything, and then you would do the trig and figure out some of this stuff. So you're not here, but I'm encouraging you to do this on your own anyway. And you might feel a little ill-equipped. And so I want to try to help you and talk about maybe some of the problems you're going to run into. Okay? So the biggest problem I think that everyone's going to have is measuring the angles. Okay? Right now, if you go outside and try to figure out, well, what's this angle? What's that angle? It could be kind of difficult. So my hope is you might have a protractor lying around the house. Somewhere in some junk drawer, you open up, you go, there's a protractor. All right. Now, I know I'm really hoping for a lot on that one, but who knows? There's a chance, right? So anyway, but what I want to do is if you do have a protractor lying around, I want to show you how you would use that. Every protractor has a little hole on it right here. That hole is that you could put a piece of string or yarn or fish line or something like that through, okay? Now, one way of using a protractor is what it shows right here in this illustration. All right, what you would do is you would put a piece of string through that hole, like I said, and tie a knot, okay, so it's hanging from that hole, and then they put a weight. They used a washer as a weight. And then while looking along the bottom edge of the protractor in the line of sight, so they're lining up their eye to whatever it is they want to look at, the top of a building, the top of a tree, the something, okay, that you line up this real nicely, and wherever this weight falls, that helps you measure the angle of elevation. Now notice where it is in the picture. It shows that it's kind of at about 55 degrees, but that's not the angle of elevation. You actually have to take that away from 90 and you get 35, and that is the angle of elevation. When you use a protractor in this way and you line up that bottom edge in your line of sight of what you're looking for, wherever the weight falls is not the angle of elevation. You have to subtract that from 90, and that is the angle of elevation. Now that can sound kind of complicated, but it's really not that hard. However, I have an easier way that we would be doing here, but it requires the help of more than one person. It's almost impossible to do by yourself. But another way of using a protractor is to lay the protractor down, or have one person rather hold the protractor in this spot. So one person's standing over here, holding this protractor down on the ground, while another person is standing right here, and with a string going through the protractor, they hold onto the string, and they are then kind of pointing the string. They hold it beyond their eyes, not just right to their eye, they hold it beyond their eyes, and they're pointing it so it's going in the direction that they want. Same thing, it's in the line of sight of what they're trying to measure. And then while they're doing that, somebody else can then come back over here and measure the angle. And whatever it shows up to be, like this one right here, it looks like it's about just almost 25 degrees, about 24 and a half, 24, 25 degrees. And so that is the angle of elevation. There's no subtract this or subtract that. It's just whatever you can get that to be, that is the angle of elevation. Now, a couple important things. The protractor cannot be sitting up on anything, obviously. It can't be sitting up higher than the person is. It has to be at the same ground level as the person, okay? This all has to be at the same level. And this person has to do a really good job of really trying to hold this string. Maybe I should have had them hold the string a little bit further out here because they need to be able to see that this is in the right line of sight. You can't just go, I think it might be right. Okay. And that will then give you the angle of elevation. So we got two ways to use a protractor. If you got a protractor lying around, you could easily create this little thing, which is actually called a sextant, or you can use this method right here, which we'd use on campus because it involves a couple people. 2 or 3 people doing this together really gives accurate results. Okay, so those are a couple ways that you could do it. But you might say, man, I don't have a protractor, and I understand. So what's the next option? Well, you can, where'd it go? Oh, I had something else in here, but it's gone now. But one of the things that you could do is you can use an app. You can use an app. All I did was go to this app store and I did a quick search, and look, I found there's Bubble Level for iPhone, there's Level, there's Protractor, there's a game, there's Toolbox Precise Tools, there's Angle Pro, Right Angle Protractor. All these are free apps that allow your phone to then measure these angles, okay? And it's that simple. And so you would basically do the same thing. You would look in line, but what you would do is you would put your phone right here. So this is now your phone. Okay, and you would look along the edge, the bottom edge of your phone, and it'll tell you what the angle of elevation is at that point. Okay, and that's pretty helpful. And you can do angle of depression, you can do angle of elevation. And so you've got the technology. If you don't have a phone and if you don't have a protractor, well, then there's even another way. And so I'm going to show you another way that I'm going to do right now. And that way is I went ahead and took Aiden outside and took a picture of him. Okay, here I've got a picture of Aiden in front of the Memorial Tower that most of you are familiar with, out in front of the school, out in front of Heidelberg Dorm. And what I've done is I measured where Aiden is standing. How far from the tower is he? Okay, and that I know. And so if we take this ruler, now look at the ruler as I move it. Okay, so it's easy for me to get that 0 degrees. So I'm just going to go off the top of his head. I'm not going to use his eye level because I didn't have him use a protractor from his eye level. So I'm just going to go from the top of his head. And honestly, it doesn't matter how tall he is. Okay, and for this problem, I'm not going to use his height. His height is not going to come into play at all. All right, so first I'm just going to draw this imaginary horizontal coming off his head. And then I'm going to use the ruler, and I'm going to go to the base of the tower. Now, you can see that I've taken a pretty bad picture here because you can't see the base of the tower, all right, because of the bushes and because of the brick that goes around the tower. But I've been here enough and looked at this thing enough that I know about where it's at. And so I'm going to say from this spot right here, that is, there we go. That is where, that would get me to the bottom or the base of the tower. Okay. And so I'm going to draw another line right there. All right. And then let's go to the peak of the tower. Now you can see the one peak kind of showing through right here, but there's another one right here, and it's kind of hard to see. This one's a little bit closer to us, so it's a little bit higher, but so I want to go off this one it would be just about the exact same height. It would be right there, but it's kind of hiding behind that tree. Again, I took a pretty lousy picture, and I apologize for that. But so here we go. So I'm going to go off that and to the top of his head. Let's see what I get here. I get 29 degrees, okay? So I've got an angle of depression of 10 degrees, and I've got an angle of elevation of 29 degrees. There we go, right to there. All right, and then we can go ahead and kind of finish these right triangles. There we go, like that. Okay, and so now we're done with the ruler, so we can get rid of that. And so while I didn't use a protractor and I didn't use an app, I am using a little bit of technology, and you might have the same resources. If you take a picture and do a little markup, you get this ruler that'll measure the angles for you. So here in this picture, what I know that this is a 29-degree angle of elevation. I know that this right here is a 10-degree angle of depression. All right. The other thing that I had to do was I had to go outside and take a big tape measure, and maybe I had to use it a couple times. Fortunately, I have a really long tape measures for doing these kind of experiments, but you might have to take a tape measure and lay it down and go, okay, well, here's 12 feet, and then here's another 12 feet to do it right. But what I did was I measured how far Aiden was from the tower, and he is, in this picture, he is 38, let's see, let's get this to right. He is 38 feet and 7 inches. Okay, so that number is going to be important. So we got a 29-degree angle of elevation, a 10-degree angle of depression, and he's 38 feet 7 inches from the tower. And that's everything I need. The question, of course, is how tall is the tower? All right. And so what I'm going to do is I'm going to work this problem out in front of you so I can show you exactly how I would do this. I got all the information from my picture and from using a tape measure outside there with Aiden. And so now let's go ahead and do this. Okay. And so, all right, I'm going to just make this real simple on myself and kind of draw a real basic little sketch. So that way I can label it. Okay, so it looks something like this. All right, now I'm interested in this whole height right here, but it's broken into two parts. So I'm going to call this H sub 1 or H1. I'm going to call this H2 or H sub 2. And obviously these are my right angles. Okay, we know that this right here is that 29-degree angle of elevation. We know that this is that 10-degree angle of depression. And we know that we've got this one that's 38 feet and 7 inches. Okay, so before I go any further, I want to make sure I know how to convert that. 38 feet and 7 inches. And so what I would do is I take 38 and multiply it by 12. And I get from that 456. And then what I do is I add my inches to that. So then I say plus the 7 more inches, and that gives me 463 inches. Because see, 38 feet and 7 inches is not the same thing as 38.7. But a lot of people think that. Okay, those are not the same thing. So you really got to convert it all the way to inches. So I'm going to say now this is 463 inches. All right, well, now let's set this up. Okay, if I'm looking at this, and I'm looking at it from the perspective of this angle that's 29 degrees, the side that I need to know is right here, which is opposite. The side I know about, which is right here, is adjacent. So then when I start thinking about, well, SOHCAHTOA, I'm dealing with opposite and adjacent, and so we go, well, that's tangent. So I can set this up and I can say, well, the tangent of that 29-degree angle of elevation is equal to opposite, H1, over adjacent, 463 inches. To get the H1 all by itself, I multiply both sides by the 463 inches. So I'm going to multiply that on both sides to keep everything equal. These cancel out, and I'm left with H sub 1 is then equal to 463 inches times the tangent of 29 degrees. Now, I know you might want to grab a calculator and plug that in, but we really don't need to do that just yet. So hang on. Now let's look at the other triangle. Okay, the other triangle, we're looking at the perspective from this 10 degrees right here. Again, we're interested in this side, which is the opposite. We know this side, which is adjacent. So again, we're going after tangent. So let's do this. So I would write the tangent of 10 degrees is equal to H sub 2 over 463 inches. I'm going to multiply both sides by 463 inches. And when I do that, of course, this cancels out. And I'm told that H sub 2 is then equal to 463 inches times the tangent of 10 degrees. Now, this is exactly what this is. It's not about. When I plug it into a calculator, then I approximate it there and now. What I want to do is I want to try to add these as exactly as I can and then approximate it at the end. Instead of saying, well, this is about some number and this is about some number and then add those up and I've approximated twice, I don't want to do that. I want to try to add them up as best I can, as most accurately as I can. So if you've got a graphing calculator, which I have, I'm going to put it all in at one time. I type in 463 times the tangent of 29 degrees, close the parentheses, plus 463 times the tangent of 10 degrees, close the parentheses. And the calculator will do it all in one step. When I hit enter, for mine, I get about 338.284482. And so what I look at is I go, man, I know that my H1 is actually equal to 338.2844, so on, so on, so on. So then I can say, well, what is it about? Well, H is about I'd round that to say 338 inches. Now, at this point, it's a really good idea to go back and double check that this number makes sense, okay? Make sure I didn't make a mistake on the calculator. So I'm going to go back to my H1 and go, well, what is 463 times the tangent of 29? And I'm just going to real quickly approximate that. And it's about 257. And I say, well, what is 463 times the tangent of 10? And it's about 82. Okay, and I'm going to add those two numbers up. 257 plus 82 gives me 339. So I go, yep, this number makes sense. But see, if I approximate this first one and approximate the second one, I get 339, which is then a little bit off of what I should have gotten. So that's why it's worthwhile to put it all in the calculator at one time. However, it is really good to go back in and to kind of chug these both twice. And that way it lets me know if my number makes sense or is close. All right. Okay. So for this, I get a height of 338 inches, but I'm still not done because at this point, what I have to do is I've got to convert it back to feet. So I go, well, what is 338 divided by 12? All right. And so I just plug that into calculator, 338 divided by 12. And what I get is I get this number, 28.166666. And it goes on forever and ever and ever. So what does that tell me? Well, it tells me this is my number of feet, okay? I've got 28 feet. But then I've got this other part right here. And so to just figure out how many inches is that, because that's not 1 inch, okay? That's not what that means, 0.1666. It doesn't mean 1 inch, it doesn't mean 2 inches. It means a specific number of inches. So in my calculator, I subtract off the 28 so that I only have the 0.16666 forever and ever. And when I multiply that times 12, it will give me the number of inches that are actually left over. So I say on my calculator minus 28. So I've got that 0.16666 times 12. And when I get times 12, I get 2. It's exactly 2 inches left over. There you go. So how tall is that tower? Well, that tower is 28 feet and 2 inches. And this is what I'm looking for. I want you to try to get outside, find something that you don't know how big it is, and do the same kind of experiment. I hope you have a great day and a lot of fun doing this.